and welcome to my workshop. Now today's video is going to be a Carveco Maker video. Now I'm going to show you how to make an engineering part. Now I require an aluminium block similar to this to connect this ball nut, okay, to the rest of the system. In other words, the ball nut's going to go here and this aluminium block is going to go on the ball nut to connect it to the 12mm thick aluminium plate that's going to go on here, and indeed all the axes, because I need 4 altogether to be able to operate the axes. So it's the connection between the ball screw and nut and the guides, okay? And I'm going to show you how to do that in Carveco Maker. So you can use Carveco Maker to make engineering parts, but there is a certain way of actually doing it. It's very easy, and I think it's actually easier than drawing it up in a 3D CAD system. So we're going to change this very rough. I don't know whether you can see that, there's too much light. So a bit of a scribble into a CAD drawing, and then create all the toolpaths in Carveco Maker to make that part. I'm going to break this video up into 2 sections, so it's going to be 2 videos. So this first one's all going to be the Carveco, because there's a lot of little tips and tricks in Carveco that I do naturally, and so it's probably better for me to go into the screen capture, and you'll be able to see everything that goes on. Then on the next video we'll machine it on my CNC mill. Incidentally, the number that comes up on the bottom of the screen here somewhere is a 5% Carveco discount code. Okay, now that you can use that on the entire range of products. So that's Carveco Maker, whether you get it monthly or whether you get it yearly subscription, or the Carveco Maker Plus, same again, monthly or yearly, or whether you purchase it. It's 5% off everything across the board, and again with the main industrial program Carveco, you also get 5% off that. So you know, it's well worth, anything is a help, especially you know, this in this climate. So we'll jump into screen capture with Carveco Maker. Okay, so here we are in Carveco Maker. So we'll start by starting a new job. Now the X, let me see, the X is going to be, well, I'm going to say 65 in the X, because I want a small amount of material to be, you know, waste stock. And oh, this is going to be 50, that's right actually, so 65 by 50. I might even make that 70, because that actual part is 60mm in length. And look, this isn't a 3D carve-in job. This is a straight 2.5D actually machine part. So I'm just going to bring the resolution down slightly. That's fine for this particular type of job. And you know, you can actually select any of the corners or the center, but this is a milling machine job, and the machine or the part offset then is going to be in this back left hand corner, which is normal for a CNC mill. And so we're working in millimeters. I'm going to press OK. So this is our base stock material. Now at the moment this is in the 3D window. We will jump into this, but you may find it easier to draw in the 2D window. Now to help us do a CAD drawing, a very accurate CAD drawing, I'm going to pull a couple of things up that you will probably find useful. So we're going to view, and the first thing we're going to pull up is show rulers. So we have the rulers here in millimeters, so we can, you know, work out exactly where we are. Now to also aid us, we can show cursor information. Now that very accurately shows us the dimensions in millimeters, exactly where we are in X and Y. Obviously we're in the 2D window, so the Z is going to show just flat 0. So that's the two main things that you would need in the two-dimensional window. Now the next thing to do is to, well, work out the exact size of the object that we want to make. And in my case, it's basically a rectangle geometry of 60 by 33.5 millimeters. So what I'm going to do is I'm going to get the square, and I'm going to start just slightly off here, just about there. I can move it later. That's what it's telling me there, that I'm going to go roughly 2 millimeters. There, that'll do, I think. About there, that'll give me that. So I'm going to draw it out and release. And here we have the opportunity to give very accurate dimensions. So we're going to say 60 millimeters here. And we're going to say for the height, which is in the Y, so is, let me see, 33.5 millimeters. Do I want that right in the middle? I'm going to actually, in actual fact, what I'm going to do is to make the drawing process a little easier. Okay, so I'm going to bring this all the way up here because I'm going to move it later. Okay, there we go. That is pretty well there. Okay, I've just thought of probably a better way of doing this. I'm going to draw the whole thing so I can use this 0, 0 corner here to be able to measure everything from. Okay, so what I'm going to do is I'm going to bring some lines in now to help me draw this. Okay, so I'm going to bring out a guideline now, if you notice, this is there's pretty well 0 there. Now what I'm going to do, I'm just going to go off the screen onto the black area. I'm going to left click, hold it down, a line appears, and now I can draw it down. Now I want to come down here exactly 17.5 millimeters. Oh, that's close. I want to edit that line, so edit, here we go. Edit guideline, and now I can place it exactly where I want it. So if I highlight, I don't have to highlight it, I just go there, just come back here and go 5. So it's minus 17.5. In other words, there's the 0 line there in the Y. See it coming down here, look, see it's minus figures. So you're moving back away from the 0. So I just wanted this line to be exactly minus 17.5 millimeters from that top line, and I got it exactly there. Apply. Okay, and that's done. Now the next line, I'm going to go and get one now for the X. I'm going to bring it out here, and I want it to be exactly 30. There. And again, right click, edit guideline, and we want exactly 30. And we're going to apply that. And we can get out of that. So what I've actually done here is that is the center position where I require the main 22 millimeter bore to be. So we'll put that bore in there now. So we get our line, we're going to come here, and you can see now it's snapped. See that the cursor has snapped to the center cross there, hopefully. And there it is. So I'm going to draw it from that, and so you can verify this. So we've just set the line, these lines up at minus 17.5 and 30 millimeters. So we know that that circle is right bang in the center of that cross. So this is why I moved this first outside geometry to this back corner, so I can use the dimensions of the ruler to accurately construct this part. So we want to make this exactly 22 millimeters diameter. 25.4 millimeters is an inch, so we're just shy of an inch. 22.0, create, and anywhere in the gray, and that's it, it's done. Obviously the distance between here and here is crucial because you know the ball screw is going to be in the center here, and the main upright from the gantry is going to be bolted to this, so there's an absolute measurement between the top of this and the center of this to be able to not bind or anything like that, and so the screw can actually move freely. So that's a crucial figure there. Look, I can shim it, or I can sort of take some a very, very small amount off later, but I'm looking for an absolute measurement here, which I've got. So the next thing to do is I need 2 holes on this line, and they need to be, let me see, 33.5 millimeters apart from each other. So what I'm going to do is get a circle in tool. We know the center of that is 30. So I want 16, let me see, 16.75, so that's 30, 40, 46.75 on that line, 46. Okay, so we started the circle. Now it needs to be 46.75. And we are on that line, and it needs to be 3 millimeters, and we're going to create it. So as you can see, we can very, very accurately place a hole or any geometry at all very accurately on a piece of material, to within less than 1/1000th of an inch. Okay, so same thing again. You just gotta, it's just a different way of working. So it's 30, so minus 1675, so that's 13.25. So it's all the way down here, 13 point. Start the circle, come here, 13.25. It's on the line, and this is 3.0 millimeters. Create and cancel and deselect. So we have our main bore and our securing. They are going to be threaded holes, but I need to drill them 3 millimeters. And that is our basic part. There's a second operation that we need to do, and that is when this is completely done, we need to turn it around and then drill in through from the top for 2 securing holes. So this is how you can make up a part in Carveco and machine it on a mill. You're just working in a 2-dimensional way of drawing. So what I'm going to do now, I'm going to select all of these. I have everything selected now, and I'm going to move this bodily now down in the material a little bit that way as well. Okay, so I can cut around, but this is still one body. We only took it up in that corner so we could take advantage of using the 0, of the drawing tool. So now we can deselect, select this one, and we can delete that guideline, select this one, select this one, and delete that guideline now. Now it comes down to toolpaths. So to make the job a little easier for us to actually get an end mill into here to start the cut, we're going to just put a little pilot hole here, like this, and we're going to say 6 millimeters. I'll create. That's done. It just makes us easier to actually put a 6mm end mill in here. So what we're going to do is first of all select this hole here and this hole here. Okay, so we have these two selected and we want to create a drilling strategy. So what we're going to do is, selected vectors, and start depth is 0 because the top of the material is going to be our 0 position. Finish depth is going to be, let me see, 20mm. The actual piece of material or stock material that we're going to use is 25mm, but we're going to run in 20. Well, actually, I'm going to take it to. I'll take it to 22mm. Plunge clearance. We're going to say 1mm. Okay, let's select a drill, and we're going to call it a 3mm end mill. Let's select that. Now we're going to edit this. Okay, so this is set up for a CNC router. So there's a lot of things we have to alter here. Step down, we're going to say 1mm. So we're going to create a peck drilling operation actually. Feed rate per second, we're going to say 3mm. And plunge rate, we're also going to say 3mm. Actually, I can probably step this up to 5mm. And this is going to be 4000. Although my speed control is done manually. Tool number 1. That's fine. So what I've actually done there is I've actually created my own peck drilling. Now later on down here it'll probably come in and say, oh, do you want a peck drill? Oh yes, there it does. Peck drill. Retraction height 5mm, that will be fine. Machine safe 5mm, that's fine. Let's set up the material because it's undefined at the moment, and we're going to tell it it's we're going to say that it's 22mm, and machine 0 is at the top, so everything is fine there, so we're going to say OK, and we're going to say this is a 3mm, 3mm, 3mm drill. Calculate now, and it's done. So we can come out of that, deselect. To deselect anything, just go over on the grey area and just do a left click, and that deselects it. This one, select. Now we're going to use an end mill to do this job. So it's toolpaths, and we're going to do a drilling again, and start 0, finish 22, select a tool, 6mm end mill, select that. Now then, step down. I'm only going to go a millimeter at a time. I like to be very conservative. It's going into aluminium, not wood. So there's 1 millimeter there. Feed rate 20 is a little fast, I think. So I'm going to say 12. Plunge rate 5 millimeter. No, I'm going to say actually 1. I'm actually forgetting I was drilling. I'm going to say 5. Plunge rate 1 millimeter per second. Now I'm going to go probably 2. I'm using an end mill here. I don't want to punch it in too quickly. Okay. Step down rate. In other words, each time we peck into the material, we're going to go in 1 millimeter depth at a time. Feed rate 5 millimeters per second. The feed rate really doesn't matter here because we're actually going straight down in. This is the one that matters, 2 millimeters per second. But I can slow that up in Mach 3. Again, my speed control is done manually. It's tool number 2. You're actually telling Carveco, well, this is a different tool to the first job. We're going to use a peck drill-in strategy, and we want you to pull out of the material by 5 millimeters. We want the safe position for the tool to be 5 millimeters, and the overall thickness of the material is 22. So just go back up here and check that we're going 22 millimeters in, although the material is 25. And that is fine. So okay, deselect that one. Okay, this is the next one. So we need to now area clearance, or bore this out. Toolpaths, area clearance, start depth, finish depth, 22. We're not really worried about an allowance. I know that little mill will, you know, it will actually machine within that tolerance, which is a couple of thou, which is fine. We now need to add a tool, and so we haven't got a tool change. It's going to be the same tool, and we're going to select that. So now I'm going to set this up now for an area clearance. Step over 1.8 millimeters. That's actually fine. Step down. Oh, that's a little bit too much. Like I say, this is aluminium. This is not wood. So we're going to say 1.5 millimeter each time. Feed rate. That's a little fast. So I'm going to say 12 millimeters. 12. So in other words, it's going to go into the material, and it's going to move around like this and spiral out. And in fact, that's what we're going to make it do next. but I only want it to actually move through the material at 12 millimeters a second. 12.75 is half an inch, so we're going to move half an inch per second. Plunger rate 6 millimeter 5. Just knock it back a little. Again, 4,000. That's maximum for my little. And this again is tool number 2. So we're telling Carveco, well, it's the same tool as the last operation. Now, we don't want to use a raster. A raster would go in here and go back and forth, and it doesn't. It would do it, but I want a nice clean bore. So to get that, use an offset strategy, and we want to start on the inside and work out. So we're going to start in the middle where we made that hole. So it's I'm going to do a ramp motion in a minute. So we're going to make it ramp into this hole and then spiral out to its finished circumference. Add ramp moves. Yes. Okay, angle 10 degrees is fine. That's probably a little bit too much. I think I only want to go half of that, 5 millimeters. Because this is only 22 millimeters in diameter, so that's actually fine. It's up to your own, discretion what you want to do there. Zigzag start height 2 millimeter above the material. That's fine. Safe said, that's okay. And it's done. Okay, so again, deselect and then reselect. So this is the next operation, and we are going to choose toolpaths. Now this time it's a profile cut on the outside, so we want the tool to run around the outside of this part. Outside, selected vector. And there again, we're not worried about allowance or finish pass. Start at 0, go down to 20. Actually, we're going to go down to 20 millimeters here. Otherwise, I'll be going into my vice jaw. That'll leave me 5 millimeters stock then to remove from the other side. So you have to sort of think a little bit sort of fourth dimensional here, which is fairly easy to do. Okay. Profile. Climb milling. I always use climb milling. It's in other words, it's going to go around clockwise. It leaves a better finish. Let's choose a tool. 6 millimeter end mill. Oh, maybe not. No, maybe not. We're going to go 8 millimeter. Change a tool. Really rip into this material, and now let me see, step over, profile, okay, step over. We're going to leave that at that, step down. We're going to go 1 millimeter, feed rate, we'll go 15. Plunge 6 millimeters a second. We'll go 5. Here again, 4000. Tool number 3. Change a tool. We're telling Carveco that we've changed the tool. Just got running back over, checking to see that I've got all this right, because you can end up machining into your jaw of your vice if you're not careful. So maximum depth 20 millimeters. I know I'm going to be gripping on the last 3 millimeters. So that means I'm going to be clear over top of the vise by 2 millimeters at the end of the cut. Yep, that's fine. Okay. Calculate. Oh, an error. Error occurred while creating the lead. Oh, okay. Okay. So I think what we'll do, instead of a lead-in move, because I just didn't like it, I'm going to do a ramp instead. Zigzag 10 millimeters, that's fine. Maximum ramp length 10. So it's 10 degrees. 10. Start height 2 millimeters, that will be fine. It just didn't like that for some reason. Okay. And that looks fine. So I can stop that. Now, when I say that sometimes you've got to think of in the 4th dimension, and I'm going to show you what that is right now. So I'm going to choose a square. I'm going to draw a square. Let me just zoom out a little. And I am going to draw a square to encompass this material in as much as I don't want to go further than about that. Actually, I can come in a little bit further there. That will be just fine. And I'm going to say create. I've got that selected. So what I'm going to do is I am now have to surface off the 5 millimeter that I've got left. So that means I'm going to take this part out of the jaws and I am going to sit it upside down and machine the 5 millimeter off, so we end up with our near finished part. To do that, we go to toolpaths, area clearance, start depth 0, finish depth 5 millimeters. Okay, add a tool, 8 millimeter, select, because we've already got an 8 millimeter in there from cutting this the outside, and we're going to step over. Oh, we can take that up a little bit. We can say 3 millimeter step up. Well, actually, that might be a bit much. 2. We'll stick with 2, and we'll stick with 1 millimeter. Feed rate, we're going to go 15. Plunger rate 5. Offset. Okay, so we're going to start on the outside. So start on the outside and work our way in. In this case, actually it really doesn't matter. We can start on the inside and go out. It doesn't matter. We can do that. Add ramp moves. Yes. 10 millimeter. Yep, that's fine. Machine safe. Thickness 22 millimeter. That really doesn't matter. And let's just see, we have got this 4000. I like to recheck everything, because at this point, you know, you've got a little bit of time invested into this part, and you don't want to, you know, make a stuff up here. So we're going to go. So this is an 8mm end mill, and this is, if I just put the 5mm, off, I know exactly what that is. Calculate. I know it's all superimposed on each other, but that really doesn't matter. Okay, so we'll go into the 3D section of this, and if it looks a bit confusing, what you can do is go here to toolpaths, and you can turn off all the toolpaths. Okay, and if you know, you can just sort of highlight and see whichever one you want. So what we're going to do is we are going to simulate all the toolpaths, and it's going to be a bit strange. So let's go to this one. Okay, so we're going to go fast. Let's simulate all of them. There we go. And there we go. Like I said, it looks a little strange. So how this looks strange is that we faced off the material and it appears to be on the wrong end. Of course, this will be flipped over and we will actually be left with this part minus this material here, which is we see as it on the base. That is one of the odd things about using Carveco to do a three-dimensional machining part, but you can actually do it. Let's have a look here. I like to have this in bronze, maybe. There we go. That looks a little better. So we'll have a look at our machined part now. Incidentally, if you want to move this around in 3D space, all you do is I'm pressing down my scroll wheel and holding it down, and you can move this around in free space. Okay, and if I bodily want to move it, so I just hover over the material, press down left and right mouse key together, and I can move it bodily around like that. Okay, so the next thing to do now, and the last thing, look, I do have to bore 2 holes in here, and I'm not sure the dimension I want yet until I get this mounted on the ball screw, and I have my plate manufactured. I'm not sure where I want these drill-ins. So for now, you know, this part is going to be finished. I'm going to be making 4 of these because I've got 2 ball screws on the y-axis and of course the x and then the z. So the next thing I want to do is to save the toolpaths. So what I want to do now is save the toolpaths. Now here they all are here. Now I want to save them separately. So we're going to move them all over here. And we're going to start off, let me see. Going to start off here. And it's a very easy process. We're going to save it to the desktop, which I find easiest to do. And look, a lot of people say to me, oh, but my machine isn't in this listing, you know, Haas and so on and so forth. All you need to do, now depending on what your machine is set up, whether it's set up as inches or whether it's set up as millimeters, just go into and save it as, in my case I'm working in millimeters, so it's G code millimeters tap. Okay, now that is basic G code language and all machines understand that. It's like English then, shall we say. So this is MIDI part, so I just put P for part 3, so it's the third part, space, and it's a 3mm drill. Operation and save. As quick as that. Okay, so I hope you've liked that video today, and don't forget, here I'll put it up again. That's the Carveco discount code of 5% across the board. And please press like and subscribe. And if you'd like to become a patron, the information will also be at the end of the video and above the comment section in the video description below. So thank you for joining me, and bye for now.